In this video, I'm going to talk about different types of statistics. So previously, I defined statistics and explained just some basic abbreviations, terminology, things like that. And so now we're going to talk about two major types of statistics. And let me remind you, I make these for my classes. I might not present everything you would need for your class if you're not in my class or your situation. So two major types of statistics would be descriptive statistics and inferential statistics. So let's start with descriptive statistics. It's got that word describe in it, so you might guess, hey, that has something to do with describing, with summarizing the data that you have available, describing a sample, describing characteristics, summarizing the characteristics of the sample that you're working with for a particular study. So an example of a descriptive statistics could be a frequency, which is a count, or a percentage to indicate how many participants in your sample meet certain characteristics. Like you might say, in our sample, we had 12 psychology majors, 3 biology majors, and 21 nursing majors, right? Those would just be frequencies. That's just a count of how many you had present. You could also present something like percentages, where you could say 30% of the sample were men, and 60% of the sample were women, and 5% were non-binary, and 5% left that question blank. All right, so those are examples of information. It's useful information. You're not necessarily testing a specific hypothesis. You're summarizing the data that's available to you. Now, some other types of descriptive statistics that could be used, they could be used as strictly descriptive, or they might be needed. You might have heard my cuckoo clock there. They also might be needed for inferential statistics, but let's talk about what they are. So one of these are measures of central tendency. Central tendency has to do with trying to determine the average or typical score in a particular set of data, set of values. And so one indicator of central tendency that many students are already familiar with when they get to my class is the mean. So the mean, many people have learned it as the average. To calculate the mean for a set of scores, you would just add up all the scores and divide by the number of scores. Now, I am not going to spend a lot of time doing examples for mean because, again, most students already know how to do it. There are plenty of good videos out there. If you want me to make a whole separate video with examples about computing mean, let me know. I'll be happy to do it, but I think most people, they kind of already know how to do it, or there's other information that's available on that. Now, another indicator of central tendency is the median. The median is the midpoint or the middle score in a data set. So what you do is you take your scores, you put them in order from lowest to highest, and then you literally just find the middle score, which works out really well if you have an even number of scores. There's a literal middle point and you say, that is my middle score, that's my median. If you have an even number of scores though, you're going to have 2 middle scores. And so what you do is you take those 2 scores and you average them together. The same way you would compute the mean, it's just 2 scores. So let's say your middle 2 scores were 2 and 3. You would just go 2 plus 3 divided by 2, which would equal 2.5. So if there are 2 middle scores because you have an even number, you do have to do a little bit of extra work and average them together. Now, we have one more indicator of central tendency, and that's the mode. And the mode is often simple to determine, especially once you have put all your numbers in order, or maybe you're getting them from a frequency distribution table that already lists their frequencies. Remember, the frequency is just a count of how many times they occur. And so the mode is the most frequently occurring score. So you look and see which one out of all these scores, which one occurred the most often. So like if you had a data set where you put your scores in order and you have 1, 1, 1, 2, 2, 3, 3, 4. All right. Those are your scores that were collected, and you didn't collect them in those order. You put them in those order. All right. The number that occurred the most often in that example was 1. All right. There were 3 ones, right? Do I remember that correctly? So since there were more 1s than other scores, the mode for that particular sample, that particular data set, would be 1. So the mode, it's the most frequently occurring score. Now, still talking about statistics that can be used for descriptive statistics, or they may be needed for performing inferential statistics. Inferential statistics are the statistics we use for our actual hypothesis testing. So in addition to indicators of central tendency, we also have indicators of dispersion among data, trying to look at how much difference, how much variability, diversity, deviation that we can see in scores. Because sometimes you'll have a data set where everybody's score is remarkably similar, and other time you'll have a data set that the scores are all over the place. And so sometimes you want to know, are the scores all very similar, or do you have a lot of different scores in your sample, in your population, in your data set? And so one very simple indicator of dispersion is the range. The way you compute the range is you take the highest score in your data set and you subtract the lowest score. All right, you just look in your data set and you say, okay, which one's the highest score? Let's say you look through and you say, okay, the highest score, maybe you're looking at test scores. The highest score anybody got on this test was a 96. The lowest score was a 52. So then you'd say 96 minus 52, that number, that's your range. All right, so the range is very simple to compute, but on its own, it's not often the most informative indicator of dispersion. So we have other indicators that are a bit more complicated and lengthy to compute. So we're going to talk in more detail about those indicators. Now, the thing about computing indicators of dispersion that have to do with variation or variability, there's a lot of steps, meaning we have to compute certain values before we can actually compute the values that we're interested in. So eventually, we're going to work up to being able to compute variance and standard deviation either for a population or a sample. Remember those words from a previous video? Population, it's everybody, and the sample is a subset, people who are participating in a particular study, perhaps. All right, so to get there, we want to get to variance and standard deviation. The thing is, we have to compute some things first. So one thing we need to compute first is this thing called a deviation score. A deviation score is an individual score minus the mean. Remember mean, that average score? So that means that first, before you can compute a deviation score, you have to compute the mean. And then you compute a deviation score for each individual score in a set. This is where I'm going to go high tech to show you about deviation scores. So we need a data set. So we abbreviate our scores with an X, and I'm going to give you a nice small data set. So we have, a 2, a 3, another 3, a 1, and another 2. All right? I just knocked something down, but we're okay. So there you have your data set. Is it backwards? I bet it is. Lucky me. Maybe I'll figure out how to invert that. All right, so we've got our data set. We need deviation scores. We need to compute the mean. So we have to add our scores together. 2 plus 3 plus 3 plus 1 plus 2. Let's do that math real quick. Do you know how hard it is to do math in your head when you're looking right at a camera and you know you're being recorded? So what we get, we have to add up our scores. We get 11. We divide by the total number of scores. We have 1, 2, 3, 4, 5 scores. 11 divided by 5 equals 2.2. Now, if you didn't watch my previous video, you might not know this symbol. The X with the bar over it, that means the mean. That's the sample mean, a mean for a sample. All right, so we have our mean. What were we supposed to do next? And folks, I do like to go nice and slow, not to insult people's intelligence, but most of my students are very intimidated by this class, by taking statistics. And so I like to go nice and slow and gentle. So anyone who does have trouble, you know, they won't get overwhelmed. And then if you're like, duh, I know what's going on, then you feel good about yourself. You're like, hey, I'm ahead of the game. I know what she's going to say next. All right, so for our deviation scores, we take each score and we subtract the mean. All right, so we've computed deviation scores. I moved the mean down here. Remember, the mean was 2.2. So 2 minus 2.2, you get negative 0.2. 3 minus 2.2, 0.8. Hello, guest.
Sorry, I don't know why I did that. I felt like it.
Because everybody wants to learn statistics because it's fascinating. And then 1 minus 2.2, negative 1.2, etc. All right, so the thing is, you might notice that we've got positive and negative scores here. This is actually going to cause a problem because if we are trying to see the typical deviation, because that's one of the things we're going to eventually try to get to. Well, what is a typical? What's the average deviation? How much does a typical score deviate or differ from the mean? Well, if we did that based on these scores, you could just take these scores, add them up, and average them, but guess what you're going to get? You're going to get 0 because of the way that they were computed. So that's not going to be very useful. It's always going to be 0. So what we do is we're going to do a different calculation where we're going to square these scores and then average them. So I'll have that in my next video. We will talk about computing sum of squares, which is going to eventually allow us to compute variation, or variance and standard deviation for both a population and a sample. So we're getting there.